Maximum size subarray sum equals k. This is a premium medium problem. It's an important problem. So given an integer array nums and an integer k, return the maximum length of a subarray that sums to k. If there is not one, return 0. So consider this subarray, this array. K is 3. That means we will be looking for subarrays with sum 3. We want to find out the maximum size subarray such that the sum of the subarray is k. K here is 3. So here is one subarray of length 1, that is 3. One more subarray 5 and minus 2, and one more subarray from 0th index to this 3rd index. This is the maximum size subarray and our result is length 4. Consider this one, k is 1. We have this one subarray with sum k and also this subarray with sum k equals to 1. So this is the maximum size subarray here. If we see this array, minus 5, 8, 2, but k is minus 4. There is no valid subarray with sum minus 4. We can just return 0, that the subarray with length 0. Let's first discuss the brute force approach. This is very inefficient, but we need that to form the intuition. So for each index, for each starting index, we can calculate the subarray sum with length 1, length 2 and so on. Like if we are starting from here, length 1, this one, length 2, 0, length 3, 5 and so on. And similarly for if we start from here, length 1 will be minus 1, length 2 will be 4 and so on. Now let's see the algorithm. It's a very brute force approach where we have two for loops for i's ranging from 1 to 0 to n. J is in range I to n. Right, for each starting position I, j is in range I to n, and I am creating the subarray. I am calculating the subarray which is from nums I to j, right, and I am calculating the sum. If the subarray sum is equals to k, then I am just updating my result. Result is initially this negative infinity, which is the length of the subarray, but every time I am getting a better subarray, will update this result. And from I to j, the subarray length will be j minus I plus 1. And after this, all this, we can return the result. But it can happen that in this for loop, we don't find any valid subarray. Then in that case, the result will be minus infinity only. So in that case, we can return 0. Now, what is the complexity here? We have two for loops, that is order of n squared, and here also we are again calculating the sum, that is again order of n. So basically totally it is order of n cube, which is very inefficient. Now we can improve this sum part, right? If we use a prefix array, prefix sum array, right? We'll use some order of n extra space, but we'll reduce this complexity from here. So how we will use a prefix sum? So consider this is the same array k equals to 3 and this is the prefix sum here. Like from here till here prefix sum is 1, here prefix sum is 1 minus 1 0, then plus 5 5, minus 2 3, plus 3 6. This is the prefix sum. But how we will use this prefix sum? So prefix sum of j is x, right? That is sum from here to here, from 0th index to jth index, and prefix sum of I minus 1, that is from here to here, from 0 to I minus 1 index. So if we want prefix sum from I to j index, so that will be prefix sum of j minus prefix sum of I minus 1, that is this part. Like nums of 4, consider this subarray here. So that will be prefix sum of 4 minus prefix sum of 4 minus 1, 3. So that is 6 minus 3, that is 3. Nums 2 to 3, we are calculating sum 2 to 3, right? That will be prefix sum of 3 minus prefix sum of 2 minus 1, 1. Prefix sum of 3 minus prefix sum of 1, So that will give me this part. So prefix sum of 3 is this part, the summation of this part, and prefix sum of 1 is summation of this part. So prefix sum of 2 to 3 will be this part. Now prefix sum of 0 to 3, that is will be prefix sum of 3 minus prefix sum of 0 minus 1 minus 1. This is undefined, right? And basically we know that prefix sum of 3 is basically from 0 to that index, right? Prefix sum of 3 is from 0 to that index. So prefix sum of minus 1 we can write it as 0. Now what improvements we made? We had a prefix sum and we are just initializing it. We are just calculating the prefix sum, and then instead of computing the sum, we are just doing this prefix sum of j minus prefix sum of I minus 1 if I greater than 0, else prefix sum of j. That's it, and the rest of the computations are same. Now still we are having two for loops, and complexity is order of n square. How do we improve this? Do we need this to for loop? So consider this prefix sum here, and also we saw, right, if prefix sum till jth index is x, right, and prefix sum, let's say prefix sum of I index is y. So at each point, let's say I am at jth index, right, what I want to achieve, let's say I am at index 4 here, right, so prefix sum is 6. So what I want to achieve? I want a subarray with some k, right? So if we don't know the starting point, let's say, what will be the starting point? If we get a prefix sum that is 6 minus k, if there is any prefix sum with 6 minus k, let's say here 6 minus 3 is 3, we have a prefix sum here at 6 minus 3, right? That means this part is 3. Get my point? So at each index j, prefix sum of j minus k we will be looking for. So we don't know the starting index at this moment. We are looking for subarrays ending at j, right? Earlier also we are thinking about subarrays ending at j, but we had our eyes fixed. But here, let's say I am at jth index, right? So I got a subarray for prefix sum of x, like the sum of this part, but I want sum of k, right? We don't know the starting point yet. So that means we need some prefix sum that will be x minus k, right? We need a prefix sum in the left part so that the value of the prefix sum is x minus k. Basically my target here is now prefix sum of j minus k. We'll just look for if prefix sum of j minus k exists in our array. So instead of storing the prefix sum in an array like this, we can store it differently. Now we are having a prefixes dictionary where key is the prefix sum and value is the index. So earlier we were having one array where for each index I was storing the prefix sum, but we found out that for each index j I have to look for some prefix sum, right, in the already processed part, whether we have that prefix sum or not, like prefix sum of j minus k is present or not. So that's why we are storing the prefix sum as key value pair. Now how you will be processing? Let's say I'm at index 0, right? We got a prefix sum of 1 with, and we'll update 1 with index 0. Then 1 minus k, that is minus 2, that is present. Is that present in this prefixes? No. Now at index 1, 1 minus 1, 0, 0 present with index 1. So we'll update it. 0 minus k, that is minus 3, that is not present here. Now this is not completely correct. I'll just correct it and we'll see why. Let's go to the second index. The sum is, prefix sum is 5. So 5 present at index 2. 5 minus k, 5 minus 3, 2. 2 is not present here. Next, at third index, the prefix sum is 3 at index 3. Now 3 minus 3 is 0. 0 is present in this array, right? So that means 0 is present at index 1, right? So from 2 to 3 there should be there should be a subarray where sum is k. So this is the subarray. Next we will move to index 4. Here this prefix sum is 6, right, at index 4. Now 6 minus k, 6 minus 3 is 3. Is 3 present here? It is 3 present at index 3. That means till third index the prefix sum is 3, and till and at 4 at index 4 the prefix sum is 6. So that means subarray 4 to 4 means the only the element nums 4 is having a value k. So one thing you notice here, we found this subarray, but we didn't find this subarray, right, from 0 to this subarray. So to find that, we need to change our prefixes subarray with 0 with minus 1, right? So if we get any subarray, if we get any prefix sum, here we got a prefix sum of 3, and then we'll look for 3 minus 3 is 0, right? And 0 is present, let's say minus 1 here. Then from 0 to that index we will find the subarray. But in that case, should we remove this 0 1? Yes, we should, because let's say here I have one prefix sum p, and also here I have some prefix sum p. Which one should I consider? Should I consider this one or this one? Because let's say I am here at jth index, right? I am looking for the prefix sum p. If I consider this one, I will get the subarray with this length. If I consider this one, I will get a better subarray because I want maximum size subarray. So if a prefix sum is already present in this prefixes, then we should not update it. If it is not present, then only we should update it. Now, what is the term complexity for this algorithm? We are just doing one pass, that is order of n, and we are storing this prefix sum in a cache, that is also order of n. So first, let's say I will take this prefix cache, and that I will initialize with 0 with minus 1. Next, I also need a running sum, that is prefix sum. Initially it will be 0. We also need the result. Initially the result, let's say I am initializing with minus negative infinity. Now for j in range, length of nums, because I am taking j as the ending index, right? I will first update the prefix sum. Prefix sum plus will be the current, the nums of I, right? Now what I am looking for is if prefix sum minus k in prefix cache, this should be nums of j. In that case, I have to update the result because we found one subarray, one valid subarray. That will be max of result, or if we are at index j, we found the prefix sum minus k in prefix cache with some index, right? That will be our starting index. Let's call it I, right? So that the length will be j minus I. So j minus prefix cache of prefix sum minus k, right? That is my current subarray length, and that's it. And then we have to update the prefix cache also, right? If prefix sum not in prefix cache, then only we'll update to get the maximum result. Then prefix cache of prefix sum will be j, right? Now that's it, and then we can return the result. If result not equals to float minus infinity, else 0, and it will be negative infinity when there is no valid subarray. Now let's run this. This works, and let's submit.